Hello everyone. Welcome to the lecture. In this lecture, we will study about the outline of Computer Networks course. This course is divided in 11 sections. Sure, here's a brief explanation of each section in the course outline for Computer Networks. First section, Overview of the course. This section provides an overview of the course, including its objectives, the topics that will be covered, and the resources that will be used. It sets the foundation for the course and prepares students for what to expect. Second section, Introduction to Computer Networks. This module is designed to provide an introduction to computer networks. It covers the basics of network architecture, including the different types of networks and topologies. Students will learn about the various network protocols that are used in computer networks and their role in network communication. Third section, Physical Layer. This module covers the physical layer of the OSI model. It introduces the students to the different transmission media used in computer networks and the various signal encoding techniques used to transmit data over these media. It also discusses modulation methods and error detection and correction techniques. Fourth section, Data Link Layer. The data link layer is responsible for transferring data between two adjacent network nodes. This module covers various data link layer protocols such as Ethernet, HDLC, and PPP. It also discusses topics such as error detection and correction, flow control, and congestion control. Fifth section, Network Layer. The network layer is responsible for delivering packets from the source to the destination across multiple network nodes. This module covers the network layer protocols such as IP, ARP, and ICMP. Students will learn about routing algorithms, subnetting, and network address translation, NAT. Sixth section, Transport Layer. The transport layer is responsible for reliable delivery of data between end-to-end connections. This module covers the transport layer protocols such as TCP and UDP. Students will learn about flow control, congestion control, and error recovery. Seventh section, Application Layer. This module covers various application layer protocols such as HTTP, FTP, SMTP, and DNS. Students will learn about the client-server model and basic network programming concepts such as socket programming. Eighth section, Wireless and Mobile Networks. This module covers wireless and mobile networks. Students will learn about wireless network standards, wireless network security, mobile IP, and mobile ad hoc networks. This module is important as wireless and mobile networks have become increasingly popular in recent years. Ninth section, Network Security. This module covers network security and discusses topics such as confidentiality, integrity, and availability. Students will learn about different security mechanisms such as firewalls, virtual private networks, VPNs, and encryption. 10th section, Network Management and Administration. This module covers network management and administration. Students will learn about network monitoring, network troubleshooting, and network configuration management. This module is important as effective network management is critical to ensure the smooth functioning of computer networks. 11th section, Advanced Topics. This module covers advanced topics in computer networks such as cloud computing, virtualization, software-defined networking (SDN), and network function virtualization (NFV). Students will learn about the latest developments in computer networks and how these technologies are shaping the future of networking. This course outline provides a comprehensive introduction to computer networks, covering topics from the physical layer to advanced networking concepts such as SDN and NFV. By the end of the course, students should be familiar with the key concepts, technologies, and protocols used in modern computer networks, and have the skills to design, implement, and manage small to medium-sized networks. Thank you. That's all for the video. We will see you in the next one.
Hello everyone, welcome to the video. In this video, we will talk about computer networks and particularly about the physical layer. So computer networks are system of interconnected of devices such as computer, printers, servers and communicate and share information with each other. The following are the basic concepts and terminologies related to computer networks. So in this video, we want to see what are the basic concepts of computer networks. So first is nodes. Nodes are important in computer networks. So nodes are devices connected to the network such as computers, servers and routers. Second is topology. Topology refers to the way in which the nodes are connected to each other within a network. Common topologies include star ring and mesh. Third is protocol. Protocols are a set of rules that govern the exchange of data between nodes on a network. Example of protocols include TCP/IP, HTTP and FTP means file transport protocol. The another important topic is bandwidth. Bandwidth refers to the amount of data that can be transmitted over a network connection in a given amount of time. It is usually measured in bits per second or byte per second. And last one is latency. Latency is the delay between the time a data packet is sent from one node on a network to the time it is received by another node. It is usually measured in milliseconds. Next is IP address. An IP address is a unique identifier assigned to each node on a network. It allows nodes to communicate with each other across different networks. And the and one other important term is domain name system. You will hear this term again and again. DNS is a system used to translate human readable domain names such as www.example.com into IP addresses that computers can use to locate servers on the internet. One another important term is firewall. Firewall is a network security device that monitors and controls the incoming and outgoing network traffic based on predetermined security rules. So these are just some of the basic concepts and terminology related to computer networks. Understanding these concepts is essential for anyone looking to work in the field of network engineering or cyber security. So thank you. That's it for the video. We will see you in the next one.
Here is a detailed account of the history of computer networking, divided into phases with time. Phase 1, early networking efforts, 1950s to 1960s. Phase 2, the birth of the Internet, 1960s to 1980s. Phase 3, the rise of client-server architecture, 1980s to 1990s. Phase 4, the World Wide Web and mobile networking, 1990s to 2000s. Phase 5, cloud computing and the Internet of Things, 2000s present. Phase 1, early networking efforts, 1950s to 1960s. In the early days of computing, computers were large, expensive, and confined to large organizations and government agencies. But as time-sharing systems and interactive computing emerged, people began to imagine a world where computers could connect and share resources. Early networking efforts focused on connecting computers within a single organization, like a university or research institution. These networks used specialized hardware and dedicated connections to transfer data between computers. Imagine a time when computers were the size of rooms and only accessible to the privileged few. But with advancements in technology, the idea of networking computers emerged, and the world was never the same. Early networking efforts sought to link computers within a single organization, allowing for the sharing of resources and information. These networks used specialized hardware and dedicated connections to transfer data between computers, paving the way for future networking technologies. Phase 2, the birth of the Internet, 1960s to 1980s. In the late 1960s, the US Department of Defense developed the ARPANET, which was the first wide-area network that used packet switching technology. The ARPANET was designed to connect multiple computers across different locations and was initially used for research purposes. As the 1970s rolled around, other government agencies, research institutions, and universities started to create their own networks, which were eventually connected to the ARPANET, collectively forming what we know today as the Internet. Can you imagine a world without the Internet? It all started with the ARPANET, a wide-area network developed by the US Department of Defense in the late 1960s. This groundbreaking technology used packet switching to connect multiple computers across different locations, enabling researchers to collaborate and share information like never before. As more organizations began to develop their own networks, the Internet began to take shape, eventually becoming the global network we know today. Phase 3. The rise of client-server architecture, 1980s to 1990s. As the Internet became more commercially oriented in the 1980s and 1990s, client-server architecture emerged as the dominant networking model. This architecture involves dividing network tasks between client devices, such as personal computers, and server devices, such as web servers or database servers, allowing for greater scalability and flexibility in network design. The 1980s and 1990s saw a shift in the Internet's purpose, as it became more commercially oriented. With this shift came the rise of client-server architecture, a networking model that revolutionized the way we access information. This architecture involves dividing network tasks between client devices, such as personal computers, and server devices, such as web servers or database servers, allowing for greater scalability and flexibility in network design. Phase 4. The World Wide Web and Mobile Networking, 1990s to 2000s. In the 1990s, the World Wide Web emerged as a major driver of Internet growth. The development of the first web browser and web server allowed for the creation of websites, which enabled easy sharing of information and resources over the Internet. The 2000s saw the rise of mobile networking, with the widespread adoption of cellular phones and the development of mobile data networks. The 1990s saw the rise of the World Wide Web, a platform that forever changed the way we share and access information. With the development of the first web browser and server, websites became commonplace, allowing for easy sharing of resources and information over the Internet. The 2000s saw the rise of mobile networking, as cell phones became more ubiquitous and mobile data networks were developed, allowing people to access the Internet from anywhere. Phase 5. Cloud Computing and the Internet of Things, 2000s present. In the 2000s and beyond, cloud computing and the Internet of Things, IoT, have emerged as major trends in computer networking. Cloud computing involves the delivery of computing resources, such as processing power or storage, over the Internet, which allows users to access applications and services from anywhere with an Internet connection. This has led to the growth of on-demand services, such as cloud storage and software as a service (SaaS), which have disrupted traditional software and storage markets. Meanwhile, the IoT involves the networking of everyday devices and objects, such as appliances, vehicles, and sensors, allowing them to collect and share data over the Internet. This has led to the development of smart homes, smart cities, and other connected systems that promise to improve efficiency, convenience, and safety. However, it has also raised concerns around data privacy and security, as well as the potential for automation to disrupt traditional jobs and industries. As these trends continue to evolve, computer networking will undoubtedly play a crucial role in shaping the future of technology and society. New technologies such as 5G wireless networks and edge computing promise to deliver faster speeds, lower latency, and greater reliability, while also enabling new applications and services. At the same time, new challenges around data privacy, security, and ethical considerations will need to be addressed to ensure that these technologies are used in a responsible and equitable manner. In conclusion, the history of computer networking has been marked by a series of transformative innovations and advancements that have changed the way we live, work, and communicate. From early efforts to link computers within a single organization, to the birth of the Internet, the rise of client-server architecture, and the emergence of cloud computing and the IoT, the evolution of computer networking has been driven by a relentless pursuit of faster, more efficient, and more connected systems. As we look towards the future, it is clear that this trend will only continue as new technologies and applications emerge to shape the next phase of the networked world. Thank you. That's all for the video. We will see you in the next one.
Hello everyone. So in this video we will see the types of computer network. So there are several types of computer networks, each designed to meet specific needs and operate over different geographical areas. Here are some of the most common network types. First is LAN, local area network. A LAN is a network that connects devices in a small geographical area, such as an office building or a campus. LAN are typically used to share resources such as file or printers and to provide internet access. Next is wide area network. A wide area network is a network that connects devices over a larger geographical area such as city or country or even the world. WAN are typically used to connect remote offices and to provide internet access. Third one is metropolitan area network, or in short MAN. A MAN is a network that covers a larger geographical area than a LAN but smaller than a WAN. MAN are typically used to connect multiple LANs within a city or metropolitan area. The next one is a wireless local area network. A wireless local area network is a type of LAN that uses wireless technologies such as Wi-Fi to connect devices. LANs are often used in public places like coffee shops, airports, and hotels. We will also study like PAN, personal area network. A PAN is a network that connects devices within a personal immediate surroundings such as a smartphone, laptop, and wearable devices. Bluetooth is a common technology used in PANs. Next one is SAN, storage area network. A SAN is a specialized network used for high-speed data transfer between servers and storage devices, such as hard drives and tape libraries. So in summaries, we can say that each network type has its own strengths and weaknesses, and the choice of network type will depend on specific needs of the organization or individual. So thank you. That's it for the video. We will see you in the next one. Hello everyone. So welcome to the video. In this video, we will talk about computer models. Computer models are important in computer networks since these are the frameworks that describes how data is transmitted and received across computer networks. The two most commonly used network models are the OSI, means Open System Interconnection model, and the TCP/IP, means Transmission Control Protocol or Internet Protocol model. The OSI model is a conceptual model that defines how data is transmitted and received across computer networks. It consists of 7 layers, each with a specific function. We can first layer is physical layer, then second is data link layer, third is network layer, fourth is transport layer, fifth is session layer, sixth is presentation layer, and seventh is application layer. We can remember these layers by a secret called a sentence, like please do not tell secret password anyone, like P for please and P for physical layer. Please do not. So D for D for data link layer. Not network layer, and not tell transport layer, secret session layer, password presentation layer, anyone application layer. So what is physical layer? Physical layer defines the physical media used to transmit data such as copper wires, optical fibers, or wireless signals. Data link layer defines how the data is packaged into frames or for transmission over the physical media. Third is network layer. Network layer defines how data is routed between different networks based on logical addressing such as IP addresses. Fourth is transport layer. Transport layer provides end-to-end communication between devices, ensuring data integrity and reliability. Fifth is session layer. Session layer establishes and manages communication sessions between devices. The sixth one and seventh one are presentation layer and application layer. Presentation layer defines how data is formatted and presented to the application layer, and application layer provides the services to the end user applications such as email, file transfer, and web browsing. So TCP/IP model is a simplified version of OSI model and is the basis for the internet. Eh, It consists of four layers like application layer, transport layer, internet layer, and network access layer. In application layer provides services to the end user applications such as email, file transfer, and web browsing. Next is transport layer. Transport layer provides end-to-end communication between devices, ensuring data integrity and reliability. Next is internet layer. Internet layer defines how data is routed between different networks based on logical addressing such as IP addresses. Fourth is network access layer. Network access layer defines how data is packaged into frames for transmission over the physical media. So in summary, we can say that main difference between the OSI and TCP/IP model is that TCP/IP model combines session, presentation, and application layers into a single layer, whereas the OSI model separates them into individual layers. Both models provide a standardized way for network engineers and developers to design, build, and troubleshoot computer networks. So thank you. That's it for the video. We will see you in the next one. Hello everyone. Welcome to the network course. In this video, we will talk about network devices and protocols. Network devices and protocols are essential components of computer networks that enable communication between devices and facilitate the transfer of data. Here is a brief explanation of some of the common network devices and protocols. First one, network devices important are router, switch, firewall, modem, and access point. So first we will talk about router. What router? Router is a networking device that forwards data packets between different networks, such as internet and a local network. Switch is a networking device that connects devices on local network and allows them to communicate with each other. Third one is firewall. Firewall is a network security device that monitors and controls incoming and outgoing network traffic to prevent unauthorized access and attacks. Firewall comes as an important concept in network security. Next is modem. Modem is a device that converts digital data from a computer into analog signals and can be transmitted over telephone lines or cable networks. Access point. An access point is a device that provides wireless connectivity to devices on a network such as laptops, smartphones, and tablets. Now we will study about network protocols. So some network protocols are like TCP/IP, HTTP, FTP, DNS, SMTP. So what is TCP/IP? Transmission Control Protocol or Internet Protocol is a suite of communication protocols used to connect devices over the internet and other networks. Next is HTTP. Hypertext Transfer Protocol is a protocol used to transfer data between web servers and client, enabling the delivery of web pages and other web client content. Next is FTP, File Transfer Protocol. File Transfer Protocol is a protocol used to transfer files between devices on a network. Next is Domain Name System. Domain Name System is a protocol used to translate domain names into IP addresses. And the next one is SMTP, Simple Mail Transfer Protocol. It is a protocol used to send and receive email messages over the internet and other networks. So in summary, we can say that there are just a few examples of network devices and protocols that are used in computer networks. Understanding how these devices and protocols works together is essential for building, managing, and troubleshooting modern computer networks. So thank you. That's it for the video. We will see you in the next one. Hello everyone. Welcome to the video. In this video, we will talk about physical layer that is an important part of computer network course. So in computer networks, physical layer is responsible for transmitting raw bits between devices. It is the lowest layer in the OSI model or the TCP/IP model, and it deals with the electrical, mechanical, or functional aspects of communication. Signals and encoding are two important concepts in the physical layer. Here is a brief explanation of each. First is signals. So in physical layer, data is transmitted in the form of electrical or optical signals. These signals can be analog or digital. Analog signals are continuous waves that vary in amplitude, frequency, or phase, while digital signals are discrete waves that represents binary data as zeros or ones. The most common types of signals used in computer networks are baseband signals and broadband signals. Baseband signals are signals that uses a single frequency to transmit data, and they are commonly used in wired networks. Broadband signals are commonly used in wireless networks. These signals use multiple frequencies to transmit data. Encoding. So encoding is the process of converting digital data into a signal that can be transmitted over a network. There are several encoding techniques used in computer networks, including Manchester encoding, differential Manchester encoding, amplitude shift key, frequency shift key, and phase shift keying. So what is Manchester encoding? Manchester encoding technique uses transitions in the signal to represent binary data, with a transition from low to high representing a 1 and a transition from high to low representing a 0. Differential Manchester encoding. This encoding technique is similar to Manchester encoding but uses the absence of a transition to represent a 1 and the presence of a transition to represent a 0. Amplitude key shift keying. This encoding technique uses different amplitudes of a signal to represent binary data, with a high amplitude representing a 1 and low amplitude representing a 0. Frequency shift keying. This encoding technique uses different frequencies of a signal to represent binary data, with one frequency representing a 1 and another frequency representing a 0. Phase shift keying. This encoding technique uses different phases of a signal to represent binary data, with one phase representing a 1 and another phase representing a 0. So in summary, we can say that physical layer is responsible for transmitting raw bits between devices, and signals and encoding are two important concepts used in this layer to ensure data is transmitted accurately and efficiently. So thank you. That's it for the video. We will see you in the next one. Hello everyone, welcome to the video. In this video, we will talk about an important concept in computer network, that is transmission media. So in computer networks, transmission media refers to the physical means by which data is transmitted between devices in the physical layer. There are three primary types of transmission media: guided, unguided, and wireless. Here is a brief explanation of each. Guided transmission media refers to media that provides a physical path for the transmission of data signals. Example of guided transmission media include twisted pair cable, coaxial cable, and fiber optic cable. Next, we have twisted pair cable. This type of cable consists of two or more copper wires twisted together to produce electromagnetic interface, and electromagnetic interface means EMI, and crosstalk. Twisted pair cable is commonly used in local area networks and telephone lines. Next, we have coaxial cable. This type of cable consists of a copper conductor surrounded by insulation, a braided shield, and an outer jacket. Coaxial cable is commonly used for cable television, high-speed internet, and other broadband applications. Fiber optic cable. This type of cable uses light to transmit data signals over a thin strand of glass or plastic. Fiber optic cable offers high bandwidth, low attenuation, and resistance to EMI, making it ideal for long-distance communication and high-speed networks. Next, we have unguided transmission media. Unguided transmission media refers to media that do not provide a physical path for the transmission of data signals. Example of unguided transmission media include radio waves, microwaves, infrared waves. So what is radio waves? Radio waves are electromagnetic waves that can be used for wireless communication. They are commonly used for mobile devices, wireless LANs, and satellite communication. Microwaves are a type of radio wave with a higher frequency that is commonly used for point-to-point communication, such as in microwave ovens and satellite communication. Infrared waves. Infrared waves are electromagnetic waves that can be used for short-range communication, such as in remote controls or and infrared data transfer. Next, we have wireless transmission media. In wireless transmission media refers to the means by which data is transmitted over a wireless network. Wireless transmission media include Wi-Fi, Bluetooth, cellular network, and satellite communication. These types of transmission media use radio waves or other electromagnetic waves to transmit data signals between devices. Next, we have transmission media. In summary, transmission media is the physical layer guide refers to the physical means by which data is transmitted between devices. Guided, unguided, and wireless transmission media are the three primary types of transmission media used in computer networks, and each has its advantage and disadvantage. Understanding the different types of transmission media is important for selecting. Hello everyone, welcome to the video. In this video of computer network, we will talk about modulation and demodulation. So as we know, modulation and demodulation are two important techniques used in physical layer of a computer network. These are used to transmit digital data over a communication channel. Here is a brief explanation of each. So modulation is the process of modifying a carrier signal to encode digital information. The digital information, also called the message signal, is combined with a high frequency carrier signal to create a modulated signal that can be transmitted over a communication channel. Modulation allows the digital data to be transmitted over a long distance without significant attenuation or interference. The three primary types of modulation are amplitude modulation, frequency modulation, and phase modulation. So first we will talk about amplitude modulation. In amplitude modulation, the amplitude of the carrier signal is modulated to represent the digital data, while in frequency modulation, the frequency of carrier signal is modulated to represent the digital data. And in phase modulation, the phase of carrier signal is modulated to represent the digital data. Next, we will talk about demodulation. So demodulation is the process of extracting the original digital information from a modulated signal. The modulated signal, which contains both the carrier signal and digital information, is received by the receiver and then demodulated to recover the original digital information. The three primary types of demodulation are amplitude demodulation, frequency demodulation, and phase demodulation. In amplitude demodulation, the modulated signal is passed through a rectifier and a low-pass filter to remove the carrier signal and recover the digital information. While in frequency demodulation, the modulated signal is passed through a frequency discriminator to recover the digital information. And in phase demodulation, the modulated signal is passed through a phase detector to recover the digital information. So conclusion, in summary, modulation and demodulation are important techniques used in the physical layer of a computer network to transmit and receive digital data over a communication channel. Modulation allows digital data to be transmitted over a long distance without significant attenuation or interference. And demodulation allows the original digital information to be extracted from a modulated signal. Different types of modulation and demodulation are used depending on the type of transmission medium and the requirements of network application. So thank you. That's it for the video. We will see you in the next one. Hello everyone. This is the last video in the section of physical layer in computer networks. In this video, we will talk about multiplexing and error detection and the error correction. So multiplexing and error detection and correction are two important techniques used in the physical layer of a computer network to to increase the efficiency and reliability of data transmission. Here is a brief explanation of each. Multiplexing is the process of combining multiple signals into a digital signal for transmitting over a communication channel. In the physical layer of a computer network, multiplexing is used to increase the efficiency of data transmission by allowing multiple signals to be transmitted simultaneously over a single communication channel. There are several types of multiplexing, including time division multiplexing, frequency division multiplexing, and code division multiplexing. So what is time division multiplexing? Time division multiplexing is called TDM in short. In time division multiplexing, each signal is divided into multiple time slots, and each time slot is allocated to a different signal. The signals are transmitted sequentially over the communication channel. Second point is frequency division multiplexing, or is FDM in short. So in frequency division multiplexing, each signal is assigned a different frequency band, and the signal is transmitted simultaneously over the communication channel using different frequency bands. The next and last multiplexing type is code division multiplexing, or CDM in short. In CDM, each signal is assigned a unique code, and the signals are transmitted simultaneously over the communication channel using different codes. Next is error detection or correction. So in error detection or correction is the process of identifying and correcting errors that may occur during data transmission. In the physical layer of a computer network, error detection or correction is used to increase the reliability of data transmission by detecting and correcting errors that may occur due to noise or other factors. There are several techniques used for error detection or correction, including parity check. In parity check, a signal bit is added to each group of bits to detect errors. If the number of ones in the group of bits is even, then the parity bit is set to 0. If the number of 1 is odd, then the parity bit is set to 1. When the data is received, the receiver can check the parity bit to determine if an error has occurred. Next is cyclic redundancy check. In cyclic redundancy check, a polynomial function is used to generate a checksum for the data. The checksum is transmitted along with the data, and the receiver uses the same polynomial function to calculate a checksum for the received data. If the checksum do not match, an error has occurred. Next is forward error correction (FEC). In forward error correction, extra bits are added to the data before transmission to allow errors to be corrected. The extra bits are used by the receiver to correct errors that may occur during transmission. So we can summarize this as follows. In multiplexing, and error detection and correction are two important techniques that are used in physical layer of a computer network to increase the efficiency and reliability of data transmission. Multiplexing allows multiple signals to be transmitted simultaneously over a single communication channel, while error detection or correction allows errors to be detected and corrected to increase the reliability of data transmission. Different types of multiplexing and error detection or correction techniques are used depending on the requirements of network application. So thank you. That's it for the video. We will see you in next one. Hello everyone. Welcome to this video. In this video, we will talk about important concepts of computer networks, that are framing and flow control. So framing and flow control are two important functions of the data link layer in computer networks. Here is a brief explanation of each. So in this slide, we will understand the framing. Framing is the process of dividing the data to be transmitted into smaller manageable units called frames. Each frame includes a header and a trailer that contains control information such as the source and destination addresses, frame sequence number, and error detection information. The purpose of framing is to provide a mechanism for identifying the beginning and end of each frame, and to allow the data link layer to retransmit any frames that are lost or damaged during transmission. Thus, flow control is the process of regulating the rate at which data is transmitted between two devices to prevent the receiver from being overwhelmed with data. Flow control is necessary because the sender may transmit data faster than the receiver can process it, leading to data loss or congestion. Next, there are two types of flow control. First is stop and wait flow control, and second is sliding window flow control. In stop and wait flow control, the sender transmits a frame and waits for an acknowledgement from the receiver before transmitting the next frame. The receiver sends an ACK or acknowledgement to indicate that the frame was received successfully. Next is sliding window flow control. In sliding window flow control, the sender can transmit multiple frames before receiving an acknowledgement or ACK insert from the receiver. The receiver sends an ACK for each frame received, and the sender keeps track of the number of outstanding frames. The sender can transmit new frames as long as the number of outstanding frames is less than a predefined window size. Flow control helps to prevent congestion and data loss by ensuring that the sender does not overwhelm the receiver with too much data. The type of flow control used depends on the specific requirements of the network application. So we can summarize this lecture as like flow framing and flow control are two important functions of the data link layer in computer networks. Framing is used to divide data into smaller, manageable units called frames, while flow control is used to regulate the rate of data transmission to prevent congestion and data loss. Different types of flow control such as stop and wait, sliding window can be used depending on the requirements of the network application. So thank you. That's it for the video. We will see you in the next one. Hello everyone. Welcome to the video. In this video, we will talk about an important lecture in computer networks. This is section is a data link layer. In this lecture, we will talk about error detection and correction. So error detection and correction is an important function of the data link layer in computer networks. Errors can occur during the transmission of data due to noise, inferences, or other factors. The data link layer provides mechanism to detect and correct these errors to ensure reliable data transmission. There are several techniques used for error detection and correction in the data link layer, including parity checking, checksum, cyclic redundancy check, and forward error correction. So first is parity checking. Parity checking is a simple technique for error detection. In this method, an additional bit called the parity bit is added to the data. The parity bit is set to 0 or 1 depending on whether the number of ones in the data is even or odd. The receiver counts the number of ones in the received data and checks if it matches the parity bit. If the number of ones does not match the parity bit, an error is detected. Next is checksum. A checksum is a more advanced technique for error detection and correction. In this method, a checksum value is calculated from the data using an algorithm. The checksum is transmitted along with the data. The receiver also calculates the checksum value using the same algorithm and compares it with the received checksum value. If the checksum values do not match, an error is detected. Next method is cyclic redundancy check. In short, CRC. This method is more important. So CRC is a more robust technique for error detection and correction. In this method, a CRC polynomial is generated based on the data. The center calculates the CRC value and appends it to the data. The receiver also calculates the CRC value and compares it with the received CRC value. If the CRC value do not match, an error is detected. CRC can also correct errors in some cases by using error correction codes. Next is forward error correction or FEC. Forward error correction is a technique for error correction that can be used in addition to error detection. In this method, additional redundant bits are added to the data to allow the receiver to correct errors. The redundant bits are calculated using complex mathematical algorithms. So we can summarize these concepts like these techniques for error detection and correction help ensure reliable data transmission in computer networks. Different techniques can be used depending on the specific requirements of the network application. So thank you for the video. We will see you in the next one. Hello everyone. Welcome to the video. In the section of data link layer, in this video we will talk about medium access control or MAC. Medium access control is a sublayer of the data link layer that is responding for controlling access to transmission medium, such as a network cable or wireless channel. In a standard network environment, the medium access control layer is responsible for coordinating the access of multiple devices to the shared transmission medium to avoid collisions and ensure efficient use of the available bandwidth. In shared networks, multiple devices may need to transmit data over the same transmission medium at the same time. Without proper coordination, multiple devices may attempt to transmit at the same time, leading to data collisions and network congestion. The MEC layer provides mechanisms for devices to coordinate their access to the transmission medium to avoid collisions and ensure efficient use of the available bandwidth. Medium access control. There are several techniques used by the MAC layer to coordinate access to the transmission medium, including like first one is carrier sense multiple access or CSMA. Second is carrier sense multiple access with collision detection, CSMA CD. Third is carrier sense multiple access with collision avoidance, CSMA CA. Fourth is token passing. So first one is CSMA, carrier sense multiple access. In CSMA, each device listens for traffic on the transmission medium before attempting to transmit data. If the medium is idle, the device can transmit its data. If the medium is busy, the device waits for a random amount of time before attempting to transmit again. CSMA is simple and effective, but it does not completely eliminate collisions. Next is CSMA CD. CSMA CD is an extension of CSMA that detects collisions and takes corrective action. In CSMA CD, a device that detects a collision stops transmitting and waits for a random amount of time before attempting to transmit again. CSMA CD is commonly used in wired Ethernet networks. CSMA CA. CSMA CA is technique used in wireless networks to avoid collisions. In CSMA CA, a device listens for traffic on the transmission medium and waits for a period of time before transmitting its data. The waiting time is chosen randomly so to avoid collisions. The receiving device sends an acknowledgement to indicate successful data reception. Next and last point is token passing. Token passing is a technique used in some networks to ensure that one device can transmit data at a time. A token is passed between devices and the device that holds the token can transmit data. After transmitting data, the token is passed to the next device in the network. So we can summarize this lesson as like these techniques for medium access control help ensure efficient use of the available bandwidth and avoid collisions in shared network environments. Different techniques can be used depending on the specific requirements of the network application. So thank you. That's it for the video. We will see you in the next one. Hello everyone. In this video of data link layer, we will study about Ethernet and LAN technologies. So Ethernet is a family of LAN technologies that use a common set of protocols and standards to net connect devices within a small geographical area such as building or campus. Ethernet operates at the data link layer of the OSI model. OSI model means Open System Interconnection, providing a reliable and efficient means of transmitting data between devices. In Ethernet LANs, each device is connected to a shared transmission medium such as coaxial cable or a twisted pair cable. Devices on the LAN communicate with each other by sending data frames over the shared transmission medium. Ethernet uses the carrier sense multiple access with collision detection CSMA-CD protocol to coordinate access to the transmission medium and avoid collisions. Ethernet frames consist of a header and data payload and a trailer. The header contains the source and destination MAC. MAC stands for Media Access Control addresses, which are used by devices to identify each other on the network. The data payload contains the actual data being transmitted, and the trailer contains error detection information such as CRC, means cyclic redundancy check code. Ethernet supports different data rates from 10 Mbps megabits per second to 400 Gbps gigabits per second, and different physical media including coaxial cable, twisted pair cable, and optical fibers. So we can summarize this as like LAN technologies such as Ethernet are used to connect devices within a limited geographical area such as building, campus, or home. LAN can be used to share resources such as printers and file servers and provide access to the internet. LANs can be connected to other LANs or wide area networks to extend the network reach and provide connectivity to remote locations. So thank you. That's it for the video. We will see you in the next one. Hello everyone. Welcome to a new section. In this section, we will talk about network layer. So this is the first video of the section. In this video, we will talk about addressing and routing. The network layer of the OSI model is responsible for routing data between different networks. One of the key functions of the network layer is to provide logical addressing so that packets can be routed to their destination. The Internet Protocol is the primary protocol used at the network layer in the TCP/IP protocol suite. Internet Protocol provides a hierarchical addressing scheme known as the IP address, which uniquely identifies each device connected to a network. An IP address is a 32-bit number that consists of a network portion and a host portion. The network portion identifies the network to which the device is connected, while the host portion identifies the individual device on that network. Next, routing is the process of selecting the best path for the data to travel between networks. Routers are devices that operate at the network layer and are responsible for forwarding packets between networks. Routers use routing table to determine the best path for packets to travel based on the destination IP address. A routing table is a database that contains information about the network and routes available to the router. Routing protocols are used to exchange information between routers and to build and maintain routing tables. There are two types of routing protocols: interior gateway protocols IGP and second is exterior gateway protocol EGP. IGP are used to exchange routing information within a single autonomous system, while EGPs are used to exchange routing information between different autonomous systems. We can summarize like addressing and routing are essential functions of network layer. Addressing provides a way to identify devices on a network, while routing ensures that data is delivered to its intended destination across different networks. So thank you. That's it for the video. We will see you in the next one. Hello everyone. In this video, we will talk about IP addressing and subnetting. This is the second video of the section in network layer. IP addressing is a key function of network layer in the TCP/IP protocol suite. An IP address is a unique identifier that is used to identify devices on a network. IP addresses are 32-bit numbers that are typically represented in dotted decimal notation such as 192.168.1.1. In IP addressing, there are two types of addresses: IPv4 means Internet Protocol version 4 and Internet Protocol version 6. IPv4 addresses are 32 bits long and are divided into 4 octets, while IPv6 addresses are 128 bits long and are typically represented in hexadecimal notation. Now we will focus on subnetting. So subnetting is the process of dividing a large network into smaller subnetworks or subnets. Subnetting is used to improve network performance, reduce congestion, and increase security. Subnets are identified by a subnet mask, which is used to divide the IP address into a network portion or a host portion. The subnet mask is a 32-bit number that consists of a string of ones followed by a string of zeros. The number of ones in the subnet mask indicates the number of bits that are used to identify the network portion of the IP address. For example, a subnet mask of 255.255.255.0 indicates that the first 24 bits of the IP addresses are used to identify the network portion, while the remaining 8 bits are used to identify the host portion. So subnetting allows network administrators to allocate IP addresses more efficiently and to manage network traffic more effectively. By dividing a large network into smaller subnets, network administrators can limit the number of devices on each subnet, which can help reduce network congestion and improve performance. Subnetting also provides a means of enhancing network security by isolating sensitive resources and limiting access to them. So we can summarize like IP addressing and subnetting are two important concepts in the network layer of the TCP/IP protocol suite. IP addresses are used to identify devices on a network, while subnetting is used to divide a larger network into smaller subnets to improve network performance, reduce congestion, and increase security. So thank you. That's it for the video. We will see you in the next one. Hello everyone. So in this video, we will talk about routing protocols. Routing algorithms and protocols are used in network layer of the OSI model to determine the best path for data to travel between different networks. There are different several routing algorithms and protocols including RIP, OSPF and BGP. RIP means Routing Information Protocol. RIP is a simple routing protocol that uses distance vector algorithm to determine the best path for data to travel between networks. Distance vector algorithm work by measuring the distance to a destination networks in terms of number of hops or routers that must be traversed to reach the destination. RIP means Routing Information Protocol is best suited for small networks with few routers. Next is Open Shortest Path First. OSPF is a link state routing protocol that uses a more sophisticated algorithm to determine the best path for data to travel between networks. OSPF routers exchange information based about the state of their links with other routers in the network. Based on this information, each router builds a complete map of the network including all the available routes. OSPF is suitable for large networks with many routers. Next, Border Gateway Protocol or BGP. BGP is exterior gateway protocol that is used to exchange routing information between different autonomous systems. BGP is used to connect different internet service providers and to route traffic between them. BGP routers exchange information about the available routes to different destinations and each router selects the best path based on its own policy rules. So So we can summarize it as like routing protocols and algorithms play a crucial role in the functioning of the internet and other large-scale computer networks. They are used to ensure that the data is delivered efficiently and reliably between different networks and to ensure that the network resources are used optimally. By using appropriate routing algorithms and protocols, network administrators can ensure that their networks are robust, scalable, and secure. So thank you. That's it for the video. We will see you in next one. Hello everyone. In this video, we will talk about IPv6, means Internet Protocol version 6. It is the latest version of the Internet Protocol IP that is used in the network layer of the OSI model to provide unique addresses for devices on a network and facilitate communication between them. IPv6 was developed to overcome the limitation of IPv4, the previous version of IP which was running out of available addresses due to the explosive growth of the internet. IPv6 addresses are 128 bits long, which provides a much larger address space compared to the 30-bit addresses used in IPv4. This allows for a virtually unlimited number of unique addresses, making it possible to assign a unique address to every device on the internet and to enable the connection of an almost limitless number of devices to the network. IPv6 also includes several other improvements over IPv4, such as better supports for multicast communication, simplified header structure, and better security features. IPv6 also supports auto-configuration of IP addresses, which means that the devices can automatically assign themselves a unique address when connected to network without the need of manual configuration. Despite the benefits of IPv6, adoption has been slow and many networks still use IPv4. This is partly due to the cost and complexity of upgrading to IPv6 and the need for interoperability between the two protocols. However, as the number of connected devices continues to grow, the need for more unique addresses will increase and the adoption of IPv6 is expected to accelerate. So thank you. That's it for the video. We will see you in the next one. Hello everyone, in this video we will talk about the transport layer section, and in this section we will talk about its services and protocols. So the transport layer of the OSI model provides end-to-end communication services between applications running on different devices. This layer is responsible for segmenting data into smaller chunks, ensuring reliable delivery of data and the providing flow control mechanism to prevent network congestion. There are two main transport layer protocols, means transmission control protocol and user datagram protocol. First, TCP, transmission control protocol. It is a reliable connection oriented protocol that provides guaranteed delivery of data. TCP creates a virtual connection between two devices before transmitting data, and it uses a variety of mechanisms such as sequencing, acknowledgement, and retransmission to ensure that data is delivered in the correct order and without errors. TCP is commonly used for applications that require reliable delivery of data such as file transfer, email, and web browsing. Next is UDP. UDP is a connectionless and unreliable protocol that provides no guarantee of delivery or order of data. UDP is faster and more efficient than TCP, but it is less reliable. UDP is commonly used for applications that require real-time transmission of data, such as video conferencing, gaming, and streaming media. Next, in addition to TCP and UDP, there are several other transport layer protocols including SCTP like Stream Control Transmission Protocol, DCCP, Datagram Congestion Control Protocol, and RSVP, Resource Reservation Protocol. These protocols provide additional features such as congestion control, security, and quality of services guarantees. We can summarize like the some services and protocols of the transport layer plays a critical role in ensuring reliable and efficient communication between applications running on different devices. By selecting the appropriate protocol and configuring the appropriate settings, network administrators can optimize the performance and. Hello everyone, in this video of Computer Network course and section transport layer, we will discuss about flow control and congestion control. Both of these concepts are two important mechanisms provided by the transport layer protocols such as TCP to ensure efficient and reliable delivery of data across a network. Flow control is the mechanism that regulates the rate of data transmission between two devices to prevent the receiver from being overwhelmed with data. Flow control ensures that the sender does not transmit data faster than the receiver can process it. TCP uses a sliding window algorithm to implement flow control, which allows the receiver to specify the maximum amount of data it can receive at a time. The sender that then sends data in chunks and the receiver acknowledges receipt of each chunk before the sender can send more data. Congestion control. Congestion control is the mechanism that prevents network congestions by regulating the rate of data transmissions on network. Congestion occurs when too much data is being transmitted on the network, which can cause delays and lost packets. TCP uses a variety of algorithms to implement congestion control such as slow start, congestion avoidance, and fast retransmit. These algorithms can adjust the rate of data transmission based on network conditions such as number of packets being transmitted and the round-trip time of packets. Overall, flow control and congestion control are critical mechanisms provided by the transport layer protocols to ensure that data is transmitted effectively and reliably across a network. By regulating the rate of data transmission, these mechanisms help prevent network congestion and ensure that data is delivered in a timely and reliable manner. So that's it for the video. Thank you. We will see you in the next one. Hello everyone. This is the last video in the section of transport layer. In this section of in last video we will talk about quality of service in transport layer. So quality of service is a mechanism provided by the transport layer protocols such as TCP that allows network administrators to prioritize certain types of traffic over others. Quality of service ensures that critical applications such as voice and video receive the necessary bandwidth and network resources to function properly, even in the times of congestion. Quality of service is achieved by assigning different levels of priority to different types of traffic based on their importance and sensitivity to delay and packet loss. Quality of service mechanism can be implemented at various levels of network stack, including the transport layer, network layer, and data link layer. In the transport layer, quality of service is implemented using a variety of techniques, including traffic shaping, traffic policing, and queue management. These techniques allow a network administrators to control the amount of traffic that is transmitted over the network and to ensure that the critical traffic is given priority over non-critical traffic. For example, a network administrator might prioritize voice traffic over file transfer traffic to ensure that the voice calls are not disrupted by the network congestion. This can be achieved by implementing QoS mechanisms that allocate more bandwidth to voice traffic and by configuring network devices to give voice traffic higher priority in the transmission queue. Overall, quality of service is a critical mechanism for ensuring that the critical applications receives the necessary network resources to function properly even in times of congestion. By implementing QoS mechanisms at the transport layer, network administrators can optimize the performance and reliability of the networks and ensure that critical applications are not disrupted by network congestion or delays. So thank you that for this video. We will see you in next one. Hello everyone. In this video, we will talk about client-server model. So the client-server model is a common architecture used in application layer of computer networks. In this model, the network application is divided in two distinct components, the client and the server. Next, client-server model. The client is the part of the application that runs on user computer or device and sends requests to the server. The client typically provides a user interface for the user to interact with the application and sends requests to the server to perform specific actions or retrieve data. The server is the part of the application that runs on a remote computer or device and receives requests from clients. The server processes these requests and sends back a response to the client, which is then displayed to the user. Next, client-server model allows for a distributed architecture where the application logic is split between the client and server. This allows for more efficient use of resources as the server can handle multiple requests from different clients simultaneously without the need for client to have its own copy of the application. Example of applications that use the client-server model include web browser and server, email client and server, file transfer protocol, and database applications. We can summarize this lecture as the client-server model is a common architecture used in the application layer of computer networks, where the application is divided into distinct components, the client and the server. The architecture allows for more efficient use of resources and enables distributed applications to be developed and deployed across our network. Thank you. That's it for the video. We will see you in the next one. Hello everyone, welcome to the video. In this video, we will talk about the protocols that are present in application layer. So the important protocols of application layer are DNS, FTP, HTTP, SMTP, POP3 and IMAP. We will provide a brief explanation of each. DNS, Domain Name System. Domain name system is used to translate human readable domain names such as www.example.com into IP addresses such as 192.0.2.1. This allows users to access websites and other network resources by typing in easy to remember domain names rather than having to remember the numerical IP address. Next is File Transfer Protocol. FTP is used for transferring files between computers on a network. It allows users to upload and download files from remote servers and supports various authentication and encryption mechanisms for secure file transfer. Next is Hypertext Transfer Protocol. HTTP is used for transferring web content over the internet. It is the foundation of the World Wide Web and enables users to access websites, web applications, and other resources on the internet. Next, Simple Mail Transfer Protocol. SMTP is used for sending email messages over the internet. It is responsible for routing and delivering messages between mail servers and supports various authentication and encryption mechanisms for secure email transmissions. Next is Post Office Protocol version 3 or POP3. It is used for retrieving email messages from a remote server. It allows users to download their email messages to their local computer and support various authentication and encryption mechanisms for secure email retrievals. Next is IMAP, Internet Message Access Protocol. IMAP is used for accessing email messages stored on a remote server. It allows users to access and manage their email messages from multiple devices and support various authentication and encryption mechanisms for secure email access. So we can summarize like application layer protocols are critical components of the modern computer networks, enabling users to access and exchange information across the internet and other network environments. So thank you, that's it for the video. We will see you in the next one. Hello everyone, welcome to the last video of the section application layer in computer networks course. So in this video we will talk about important concepts like web services and APIs. It allows different software applications to interact with each other over the internet. Here is a brief explanation of each. Web services. Web services are software components that provide standardized communication protocols over the internet, allowing applications to exchange data and invoke each other functions. Web services are typically based on open standards like XML, SOAP, and REST. Can be accessed using standard internet protocols like HTTP and HTTPS. Next is application layer, application programming interfaces, or APIs in short. APIs are sets of rules and protocols that enable software applications to communicate with each other. APIs specifically specify the types of requests that can be made, the format that should be used, and the expected response from the server. APIs can be used to access a wide range of services such as social media platforms, payment gateways, and cloud storage providers. So we can conclude like web services and APIs are often used in combination to provide powerful and flexible integrations between different applications. For example, a mobile application might use a web service to retrieve data from a server and then use an API to send that data to a social media platform for sharing. This allows developers to build complex and sophisticated applications by leveraging the capabilities of other services and platforms. Thank you. That's it for the video. We will see you in the next one. Hello everyone, welcome to the video. This is a new section and the first video is about cellular networks. Cellular networks are a type of wireless communication network that enables mobile devices to connect to the internet using radio waves instead of wired connections. In computer networks, cellular networks are an important technology that support a wide range of mobile applications such as voice calls, messaging, internet browsing, and video streaming. The evolution of cellular networks has seen several generations of technologies. each with different capabilities and features. Here are the main generations of cellular networks. First generation. 1G was introduced in 1980s and enabled analog voice communication over cellular networks. Second is second generation. 2G was introduced in early 1990s and enabled digital voice communication and text messaging. The Global System for Mobile Communication (GSM) is a popular 2G cellular network standard that is still used in many parts of the world. Third generation. 3G was introduced in the early 2000s and enabled mobile internet browsing and video streaming. 3G networks offered faster data transfer speed compared to 2G networks, which made it possible to use mobile devices for more advanced applications. Fourth generation 4G was introduced in late 2000s and provided even faster data transfer speeds than 3G networks. 4G networks enabled high quality video streaming, online gaming, and other bandwidth intensive applications. 5G fifth generation. 5G is the latest generation of cellular networks and offers even faster data transfer speeds than 4G networks. 5G networks are designed to support a wide range of new applications such as augmented reality, autonomous vehicles, and remote surgery. So we can summarize like cellular networks use a variety of technologies to enable wireless communication between devices, including radio frequencies, signals, antennas, and base stations. These technologies enable mobile devices to connect to the internet from nowhere, anywhere within the coverage area of a cellular network, making it a popular choice for people who need to stay connected while on the move. Thank you. That's it for the video. We will see you in next one. Hello everyone. In this video, we will talk about Wi-Fi and Bluetooth. Wi-Fi and Bluetooth are two important wireless communication technologies used in computer networks. Wi-Fi is a wireless networking technology that allows devices to connect to the internet or a local area network without the use of cables or wires. Wi-Fi uses radio waves to transmit data between devices and access points that are connected to the network. The Wi-Fi standard is defined by the Institute of Electrical and Electronical Engineers like IEEE and 802.11 protocol, which has several versions such as 802.11a, 802.11b, and 802.11g, 802.11n, 802.11ac, and 802.11ax, also known as Wi-Fi 6. Wi-Fi networks are commonly used in homes, offices, public spaces, and other areas where people need to connect to the internet or a network wirelessly. Wi-Fi enables devices such as smartphones, laptops, tablets, and smart home devices to connect to the internet and communicate with each other over a wireless network. Bluetooth. Bluetooth is another wireless communication technology that enables devices to connect and communicate each other wirelessly. Bluetooth is designed for short-range communication, usually within a range of 10 meters or less, and is commonly used for connecting devices such as headphones, speaker, keyboards, and mic to a computer or mobile device. Bluetooth uses a technology called frequency hopping stream speed spectrum (FHSS) and to avoid interference from other wireless devices in the same frequency range. Bluetooth also has several versions such as Bluetooth 1.0, Bluetooth 2.0, and Bluetooth 3.0, Bluetooth 4.0, Bluetooth 5.0, and Bluetooth 5.2, each with different features and capabilities. So we can summarize like Wi-Fi and Bluetooth are often used together to enable wireless connectivity and communication between devices. For example, a laptop may connect to a Wi-Fi network to access the internet, while a Bluetooth mouse may connect to the same laptop to enable wireless cursor movement. So thank you. That's it for the video. We will see you in the next. Hello everyone. In this video, we will talk about ad hoc networks and sensor networks. These two types of wireless networks commonly used in wireless and mobile networks. So what is ad hoc networks? Ad hoc networks are wireless networks that are formed spontaneously between a group of wireless devices without the need for any existing infrastructure or general central control. In an ad hoc network, each wireless device acts as a router and forward data packets to other devices in the network. Ad hoc networks are commonly used in situations where there is no pre-existing network infrastructure or when the network needs to be set up quickly. such as in disaster response scenarios or military operations. Sensor networks, on the other hand, are networks of small wireless devices called sensors that are used to collect and transmit data from the physical environment to a central data processing unit. Sensor networks are commonly used in wide range of applications such as environment monitoring, surveillance, healthcare. In a sensor network, each sensor is equipped with a small processor, memory, and a wireless transceiver and can communicate with other sensors in the network to form a distributed data collection and processing system. We can summarize like both ad hoc networks and sensor networks are challenging to design and manage due to the lack of centralized control and the limited resource of the individual devices. In ad hoc networks, the device must cooperate to establish and maintain the network topology and route data packets efficiently. In sensor networks, the device must optimize their energy usage to prolong the battery life and ensure that the network remains functional. As such, specialized routing and data processing algorithms have been developed for both types of network to ensure address these challenges and improve their performance. Thank you. That's it for the video. Hello everyone, welcome to a new section. This is the first video of section. In this video, we will talk about security threats and attacks. Network security is concerned with protecting computer networks from unauthorized access, attacks, and other security threats. There are several types of security threats and attacks that can compromise the security of computer network. Here are some of the common security threats and attacks in computer network security. Malware. Malware is a type of software that is designed to harm or exploit a computer network. Malware includes viruses, bombs, trojans, and other types of malicious code that can cause damage to a network by stealing data, corrupting files, or disrupting normal network operations. Phishing. Phishing is a type of social engineering attack where attackers trick users into giving away sensitive information such as password, username, and credit card numbers. Phishing attacks are usually carried out through email, social media, or other forms of electronic communication. Next is DOS attacks. Denial of service attacks are designed to overload a computer network with traffic so that it becomes unavailable to users. Attackers typically flood the network with a high volume of traffic or use other methods to disrupt network operations. MITM attacks. In MITM man-in-the-middle attacks, attackers intercept the communication between two parties in a network and secretly observe, modify, or steal data. MITM attacks are often carried out by exploiting vulnerabilities in the network protocols or using fake access points or routers to intercept traffic. Password attacks. Password attacks are designed to steal passwords or break password encryption to gain access to a network. Password attacks can take many forms including brute force attack, dictionary attacks, and phishing attacks. Networks intrusion involves unauthorized access to a computer network by an attacker. Intruders can gain access to a network by exploiting vulnerabilities in the network devices or by using stolen credentials. Data breach. Data breach involves the theft of exposure of sensitive data from a network. Data breach can occur through malware infections, phishing attacks, or other types of security breaches. We can summarize like to protect a computer network from these security threats and attacks. It is essential to implement security measures such as firewalls, intrusion detection and prevention system, encryption, access control, and security monitoring tools. Regular security audits and assessments can help identify vulnerabilities and reduce the risk of security breaches. So thank you. That's it for the video. We will see you in the next. Hello everyone. In this video, we will talk about cryptography and encryption. Cryptography is the practice of secure communication in the presence of third parties or adversaries. It involves techniques for encryption and decrypting messages to ensure that only the intended recipients can read the message content. Cryptography plays an important role in network security because it enables secure communication over public network such as internet. Encryption is a core concept in cryptography. It is the process of transforming plain text or data into a coded or scrambled format that can only be understood by someone with corresponding key or passwords. Encryption ensures that even if an attacker intercepts the messages, that will not be able to read or understand the content without the correct decryption key. There are two primary types of encryption in network security. First is symmetric encryption. This type of encryption uses a single secret key to both encrypt and decrypt data. The same key is used for by both the sender and receiver, which means that the key must be securely exchanged before communication can begin. Symmetric encryption is fast and efficient, but it requires a secure way to exchange the encryption key. Next is asymmetric encryption. This type of encryption uses a pair of keys, a public key and a private key, to encrypt and decrypt data. The public key is freely available to anyone, while the private key is kept secret by the owner. The sender encrypts the messages using the recipient's public key, and the recipient decrypts the message using their private key. Asymmetric encryption is slower than the symmetric encryption because it is more secure because the private key never leaves the owner's possession. Summary. In summary, cryptography and encryption plays a vital role in network security by providing secure communication channels that protect data from unauthorized access and tampering. So thank you. That's it for the video. We will see you in the next one. Hello everyone. In this video, we will talk about authentication and authorization in network security. These are two critical concepts in network security that help to ensure that only authorized users can access network resources and data. Authentication is the process of verifying the identity of a user or system before granting access to network resources. It involves providing some form of credentials such as username or password to prove that the user is who they claim to be. Authentication helps to prevent unauthorized access to network resources and data. There are several types of authentication mechanisms, including password-based authentication. This is the most common type of authentication mechanism where users provide a username and password to gain access to a system or network. Next is two-factor authentication. This involves requiring users to provide two types of authentication such as password and one-time code sent to their mobile phone to gain access to a system or network. Next is biometric authentication. This involves using physical characteristics such as fingerprints or facial recognition to verify the identity of a user. Authorization, on the other hand, is the process of determining what actions a user or system is allowed to perform once they have been authenticated. Authorization helps to ensure that only authorized users can access and modify network resources and data. There are several types of authorization mechanisms, including role-based access control, attribute-based access control, rule-based access control. So these three types of authorization. So in role-based access control, it involves assigning user specific roles or permissions based on their job responsibilities of job titles. For example, an employee in the HR department may have access to employee records, while an employee in the IT department may have access to system logs. This in attribute-based access control. This involves granting access based on a user's attributes such as their department, location, or job title. Rule-based access control. This involves defining specific rules or policies that dictate what action a user or system can perform. For example, a rule may state that only users in the accounting department can access financial data. So we can summarize like authentication and authorization are critical components of network security that work together to ensure that only authorized users can access and modify network resources and data. Authentication verifies the identity of a user, while authorization determines what actions that user is allowed to perform. So thank you. That's it for the video. We will see you in the next one. Hello everyone. In this video, we will talk about firewalls and intrusion detection prevention system like IDS or IPS. These are two important tools in the network security that help to protect networks and systems from unauthorized access and attacks. A firewall is a security system that monitors and controls network traffic based on a set of predefined rules. It acts as a barrier between a private network and the public internet, filtering traffic to prevent unauthorized access and potential attacks. Firewalls can be hardware and software based that are typically configured to allow or block traffic based on the source or destination IP address, ports, and protocols. Firewalls can be set up to provide different levels of security. For example, a basic firewall might be configured to allow all traffic from inside the network to go out to the internet, but block all incoming traffic from the internet. More advanced firewalls can be configured to block traffic from a specific IP address or restrict traffic to specific application or protocols. IDS Intrusion Detection System. It is a security tool that monitors network traffic for suspicious activity and alerts network administrators when potential threats are detected. IDS systems can be configured to detect specific types of attacks such as malware infections or unauthorized access attempts. I, Intrusion prevention systems are similar to intrusion detection systems but also have the ability to take action to prevent potential attacks. IPS systems can be configured to block traffic from specific IP addresses or block specific types of traffic that are known to be associated with certain types of attacks. Both IDS and IPS systems work by analyzing network traffic and comparing it to a set of predefined rules or patterns. When a potential threat is detected, the system can alert network administrators or take actions to prevent the attack. So we can summarize like firewalls and intrusion detection and prevention systems are critical tools in network security that help to protect networks and its systems from unauthorized access and attacks. Firewalls acts as a barrier when a private network and the public internet filtering traffic to prevent unauthorized access, while IDS and IPS systems monitor network traffic for suspicious activity and can take actions to prevent potential attacks. So thank you. That's it for the video. We will see you in the next one.
Hello all. Welcome to a new section, Network Management and Administration. This is the first video of the section. In this video we are going to study about network planning and design. Network planning and design are critical processes in network management and administration that help to ensure that networks are optimized for performance, scalability, and security. Network planning involves the process of identifying the requirements for a network, including the number of users, types of applications, and bandwidth needs. It also involves determining the physical layout of the network, including the locations of servers, routers, switches, and other network devices. The design phase involves the creation of a network architecture that meets the requirements identified in the planning phase. The design phase includes the selection of network hardware and software, as well as the configuration of network protocols and security features. In network planning and design, several factors need to be considered, including 1. Scalability. The network must be designed to accommodate growth and expansion as the organization's needs change over time. 2. Performance. The network must be designed to deliver reliable and fast performance, with minimal latency and downtime. 3. Security. The network must be designed to protect against unauthorized access, data breaches, and other security threats. 4. Redundancy. The network must be designed to have redundancy built in, with backup devices and systems in place to ensure that network resources are always available. 5. Cost. The network must be designed to meet the organization's needs within its budget constraints. Once the network planning and design are complete, network administrators must implement and manage the network infrastructure. This involves configuring and maintaining network devices, monitoring network performance, and troubleshooting issues as they arise. We can summarize this lecture as follows. In summary, network planning and design are critical processes in network management and administration that help to ensure that networks are optimized for performance, scalability, and security. Network administrators must carefully consider factors such as scalability, performance, security, redundancy, and cost when planning and designing network infrastructure, and they must be able to implement and manage the network infrastructure effectively. Thank you. That's all for the video. We will see you in the next one.
Hello everyone, welcome to the video. In this video, we will talk about network monitoring and performance. Network monitoring and performance analysis are important components of the network management and administration. This process involves the use of tools and techniques to monitor network activities and analyze network performance with the goal of ensuring that the network is operating at peak efficiency and identifying and addressing potential issues before they become major problems. Network monitoring involves the continuous collection and analysis of data about network activity, including traffic patterns, bandwidth usage, and device activity. That this data is typically collected by network monitoring tools such as network traffic analyzers or packet snippers, which can provide real-time visibility into network activity. Performance analysis involves the use of data collected through network monitoring to identify potential issues that may be impacted network performance. For example, performance analysis tools can help to identify bottlenecks or congestion points in the network or detect unusual patterns or activity that may indicate a security threat or other issues. Network monitoring and performance. Network monitoring and performance analysis can be used to address a variety of network management challenges, including capacity planning, troubleshooting, security, and compliance. So, capacity planning, by monitoring network activity and analyzing performance data, network administrators can identify trends and anticipate future network capacity needs. Troubleshooting. Network monitoring performance analysis can be used to quickly identify troubleshoot issues that are impacting network performance. Next is security. Network monitoring can help to detect and identify potential security threats such as malware infections or unauthorized access attempts. Next is compliance. Network monitoring and performance analysis can help to ensure that the network is compliant with regulatory requirements such as data privacy or security standards. So in summary, we can say like network monitoring and performance analysis are important components of network management and administration. These processes involves the use of tools and techniques to monitor network activity and analyze network performance with the goal of ensuring that the network is operating at peak efficiency and identifying and addressing potential issues before they become major problems. So thank you. That's it for the video. We will see you in the next one.
Of the section. In this video we will study about configuration management and fault management. Configuration management and fault management are two important processes in network management and administration. Configuration management involves the process of managing and maintaining the configuration of network devices, while fault management involves identifying, isolating, and resolving faults or issues that may arise within the network. Configuration management is critical to ensuring that network devices are properly configured and optimized for performance and security. This involves the use of tools and techniques to manage the configuration of network devices, such as routers, switches, and firewalls. Configuration management tools can be used to track changes to network configurations, automate configuration updates, and ensure that devices are reconfigured to comply with organizational policies and security standards. Fault management involves the use of tools and techniques to identify and address issues that may arise within the network, such as device failures, network congestion, or performance degradation. Fault management tools can be used to monitor network devices and traffic, analyze data to identify issues, and provide alerts or notifications when issues are detected. Network administrators can use this information to quickly identify and address issues, minimizing downtime, and minimizing the impact on users and applications. In summary, configuration management and fault management are important processes in network management and administration. Configuration management helps to ensure that network devices are properly configured and optimized for performance and security, while fault management helps to identify and address issues that may arise within the network, minimizing downtime, and minimizing the impact on users and applications. By effectively managing configuration and faults, network administrators can ensure that the network operates efficiently and reliably, supporting the needs of the organization. So, thank you. That's all for the video. We will see you in the... Hello everyone. This is the last video of the section. In this video we will study about network virtualization and cloud computing. Network virtualization and cloud computing are two key technologies in network management and administration that have revolutionized the way networks are designed, deployed, and managed. Network virtualization involves the creation of virtual network devices and resources, such as virtual routers, switches, and firewalls, that can be managed and configured independently from physical devices. TS allows network administrators to create virtual networks that are isolated from one another, providing increased security and flexibility. Virtualization also enables the use of software-defined networking, SDN, and network function virtualization, NFV, which can automate network management tasks and improve network performance and reliability. Cloud computing involves the delivery of computing resources, including storage, applications, and infrastructure, over the Internet. Cloud computing allows organizations to access computing resources on demand, reducing the need for costly on-premises hardware and software. Cloud computing also enables great flexibility and scalability, as organizations can quickly and easily add or remove resources as needed. In network management and administration, network virtualization and cloud computing can provide a range of benefits, including increased scalability. Virtualization and cloud computing enable network administrators to quickly and easily add or remove resources as needed, supporting the needs of the organization as it grows and changes. Greater flexibility. Virtualization and cloud computing enable network administrators to quickly and easily configure and manage network resources, supporting the needs of different applications and workloads. Improved security. Virtualization and cloud computing enable network administrators to create isolated virtual networks that are more secure than traditional physical networks. Lower costs. Virtualization and cloud computing can help to reduce the cost of network management and administration, as organizations can avoid the need for costly on-premises hardware and software. In summary, network virtualization and cloud computing are two key technologies in network management and administration that can provide a range of benefits, including increased scalability, greater flexibility, improved security, and lower costs. Network administrators should carefully consider the potential benefits and challenges of these technologies when designing and managing network infrastructure. So, thank you. That's all for the video. We will see you in the next
seconds. Hello everyone, welcome to the last section of this course. In this section you will study about advanced topics of computer networking like software-defined networking, SDN, network function virtualization, NFV, Internet of Things, IoT, networking and big data, and cloud networking. So the first video is devoted to software-defined networking, SDN. Software-defined networking, SDN, is an approach to network management and design that separates the control plane from the data plane, enabling centralized control and programmability of network resources. In traditional networks, network devices, such as routers and switches, handle both the control and data planes. With SDN, the control plane is managed by a centralized controller, while the data plane is managed by the network devices. SDN provides a range of benefits, including centralized control. SDN enables network administrators to centrally manage and configure network resources, simplifying network management and improving network security. Programmability. SDN allows network administrators to programmatically control network resources, enabling automation and orchestration of network tasks. Agility. SDN enables network administrators to quickly and easily make changes to network configurations, supporting the needs of different applications and workloads. Scalability. SDN enables network administrators to quickly and easily add or remove network resources as needed, supporting the needs of the organization as it grows and changes. SDN is typically implemented using an SDN controller, which is a software application that manages network resources and communicates with network devices using open protocols, such as OpenFlow. The SDN controller provides a centralized view of the network and allows network administrators to configure and manage network resources using a simple and consistent interface. SDN is often used in conjunction with other network technologies, such as network function virtualization, NFV, and network virtualization, to create more flexible, scalable, and agile network architectures. Summary of the lecture. SDN is an approach to network management and design that separates the control plane from the data plane, enabling centralized control and programmability of network resources. SDN provides a range of benefits, including centralized control, programmability, agility, and scalability, and is typically implemented using an SDN controller. Hello everyone, welcome to the second video of the section, that is Network Function Virtualization, NFV. Network Function Virtualization, NFV, is an approach to network architecture that involves the virtualization of network functions, such as firewalls, routers, and load balancers, that traditionally require dedicated hardware. NFV enables network administrators to deploy network functions as software applications on standard servers, reducing the need for expensive, specialized hardware. NFV provides a range of benefits, including cost savings. NFV enables network administrators to reduce the cost of network infrastructure by eliminating the need for expensive, specialized hardware. Scalability. NFV enables network administrators to quickly and easily add or remove network functions as needed, supporting the needs of the organization as it grows and changes. Flexibility. NFV enables network administrators to easily configure and manage network functions, supporting the needs of different applications and workloads. Agility. NFV enables network administrators to quickly and easily make changes to network configurations, supporting the needs of different applications and workloads. NFV is typically implemented using virtual machines, VMS, or containers, which are software environments that enable the deployment of applications in a lightweight and isolated manner. Network functions are deployed as VMS or containers, which can be easily moved between different physical servers or cloud environments as needed. NFV is often used in conjunction with other network technologies, such as software-defined networking, SDN, and network virtualization, to create more flexible, scalable, and agile network architectures. In summary, NFV is an approach to network architecture that involves the virtualization of network functions, such as firewalls, routers, and load balancers, that traditionally require dedicated hardware. NFV provides a range of benefits, including cost savings, scalability, flexibility, and agility, and is typically implemented using virtual machines or containers. Thank you. That's all for the video. We will see you in the next one. Hello everyone, welcome to the third video of the section, that is Internet of Things, IoT, networking. The Internet of Things, IoT, is a network of physical objects, devices, vehicles, buildings, and other items that are embedded with sensors, software, and connectivity to enable the collection, exchange, and analysis of data. IoT networking involves the communication between these devices and the exchange of data over the Internet. IoT networking provides a range of benefits, including data collection and analysis. IoT devices can collect and exchange data in real time, enabling organizations to monitor and analyze various aspects of their operations and environment. Automation and control. IoT devices can be used to automate various processes and control systems remotely, reducing the need for manual intervention. Improved efficiency. IoT devices can be used to optimize processes, reduce waste, and improve resource utilization, leading to improved efficiency and cost savings. Enhanced customer experience. IoT devices can be used to provide personalized services and experiences to customers, improving customer satisfaction and loyalty. IoT networking involves a range of technologies, including wireless networking protocols such as Wi-Fi, Bluetooth, Zigbee, and cellular networks. IoT devices are often connected to cloud-based platforms, which enable the collection, storage, and analysis of data generated by the devices. Security is a key consideration in IoT networking, as IoT devices are often connected to the Internet and can be vulnerable to cyber attacks. IoT devices must be designed with security in mind, including encryption and authentication mechanisms to protect against unauthorized access. In summary, IoT networking involves the communication between physical objects, devices, and other items that are embedded with sensors, software, and connectivity to enable the collection, exchange, and analysis of data. IoT networking provides a range of benefits, including data collection and analysis, automation and control, improved efficiency, and enhanced customer experience. IoT networking involves a range of technologies, including wireless networking protocols and cloud-based platforms, and security is a key consideration in IoT networking. Thank you. That's all for the video. We will see you in the next ones. Hello everyone, welcome to the fourth and last video of the section that is Big Data and Cloud Networking. Big data refers to the large volume of data, both structured and unstructured, that is generated by various sources, such as social media, sensors, and machines. Big data analysis involves the processing and analysis of this data to derive insights and inform decision-making. Cloud networking refers to the use of cloud computing technologies to enable the networking of devices and applications over the Internet. Cloud networking provides a range of benefits, including scalability, flexibility, and cost savings. When it comes to big data analysis, cloud networking provides an ideal platform for processing and analyzing large volumes of data. Cloud-based big data solutions, such as Amazon Web Services, AWS, and Microsoft Azure, provide the infrastructure and tools needed to store, process, and analyze large volumes of data. Cloud networking also enables the deployment of big data applications in a more scalable and flexible manner. Cloud-based big data applications can be easily deployed and scaled up or down as needed, allowing organizations to optimize their infrastructure to meet changing business needs. Another benefit of cloud networking for big data is the ability to perform real-time analysis. Cloud-based big data solutions can analyze data in real time, enabling organizations to make more informed decisions based on up-to-the-minute data. However, there are also some challenges associated with big data and cloud networking. For example, managing and securing large volumes of data can be complex, and organizations need to ensure that appropriate security measures are in place to protect the data. Additionally, the cost of cloud-based big data solutions can be a concern for some organizations. In summary, big data and cloud networking are closely linked, with cloud networking providing an ideal platform for the processing and analysis of large volumes of data. Cloud-based big data solutions offer scalability, flexibility, and real-time analysis capabilities, but also pose challenges related to data management and security. Thank you. That's all for the video.